Hello everyone, let's get started with part 4 of chapter 3. In chapter 3, we are covering empirical tools of public finance. And in this part, we are going to talk about cross-sectional regression analysis. So we talked about the gold standard of empirical research, which is randomized trials. However, when it's not available, what we get is observational data. And with observational data, we have time series analysis. There's a storm outside. There's a time series analysis, cross-sectional regression analysis. We're going to talk about quasi-experiment and structural modeling in part 5. Okay, we are now on part 4. We covered time series analysis in part 3. Let's get started with cross-sectional analysis. So this is statistical method for assessing the relationship between two or more variables while holding other factors constant. So cross-sectional is basically comparing many individuals at one point of time. So for instance, folks, if we look at this, right? If we look at the labor supply, so this is the number of hours worked, I'm going to put hours worked as a function of, let's say, alpha plus beta, okay, temporary assistance to needy families benefit level. So this is the money you're receiving in terms of government help. Let's put theta, another parameter. These are all going to be estimated parameters. So if you know a little bit about regression analysis, that's exactly what is going on. This could be, for instance, like number of kids and all the other variables, the mother's theta, mother's income. So income will be related to this. So your so on and so forth, you can control for everything. So when you control for everything else, you're doing K-Ter's parables, holding everything else constant. So you're looking at the relationship between temporary assistance to needy families benefit level and labor supply of. You can put I as a subscript. I refers to woman I, right? Woman through 1 through, we don't have their names, right? We give them numbers. 1 through capital N is the number of observations. So we are comparing many individuals at one point of time. So by varied regression, quantify the extent to which two series covary. So this, if I only included these two things, right? Regressed labor supply on temporary assistance to needy families benefit level, that would be bivariate because only one variable on the right hand side. We call this explanatory variable or independent variable. I will be posting some video links to the managerial economics course where I teach this topic a little bit in more detail. So bivariate regression, quantify the extent to which two series covary, but across different people, not across periods of time. So for instance, this is a temporary assistance in needy families, benefit cuts, and labor supply. This is a bivariate regression. This is the amount of temporary assistance to needy families benefits received. This is the benefit a single mother is receiving. And this is the labor supply hours per year. So for instance, a person works 0 hours when faced with $5,000 benefits. This is individual 1. This is what it means to a cross-sectional data set. Another person works 90 hours when faced with $4,550 in benefits. Another person, okay, we're not going to go to another person. So I get excited sometimes. The downward sloping line shows the negative correlation between the benefits and labor supply. So you have 2 points, you connect them, there is a determined relationship, okay? So the slope of this line is rise over run, 1000. Slope is negative number, negative. It's negative because it's downward sloping, 1000. Rise over run, 5000. So it's going to be minus 0.2, or it's going to be minus 1 over 5. Okay? Which means that $1 reduction in benefits leads to 0.2 hours of work. If you reduce benefits by $10, okay, so you're going to work 2 more hours. You reduce people's benefits by $10, 2 hours of work will be added to labor supply. So this is a determinant relationship. How do we do this with regression? We'll talk about that. So with 2 data points only, the line fits perfectly. That's when I say it's a determinant relationship. That means with 2 points, you have a perfectly fitting line. However, in real life, in real data, we see many more individuals. Okay, so regression takes the correlation further by finding a line that best fits the data. Describes relationship between dependent variable, labor supply, dependent variable. Remember, this is our joke that's going on. We call it Freddy Krueger effect. Labor supply, dependent variable, is a function of benefit, 10th benefit. So it's the independent or explanatory variable. So this is dependent variable, left hand side, we're trying to explain, and 10th benefits is the independent variable. Regression doesn't mean causality. I want you to know that. It's a different way of establishing strong relationship, but you need a little bit more than regression, just regression to establish causality. So current population survey actually collects, Bureau of Labor Statistics, current population survey collects information on sources of income, hours of work, health insurance, number of kids, so on and so forth. If you click on this link, you will get the information on CPS. CPS every month surveys 50 to 70,000 American citizens. This is a random sample, okay? This is a source of many official government statistics freely available to public. Okay, figure 4 we're about to see shows hours of work per year on y-axis for single mothers in the CPS data against the temporary assistance to needy families benefits on the x-axis. So you have benefits here, and this is their labor supply. This is the real data. So one group very, very high benefit levels, average hours of work they have is about 550. So these are the group of mothers that earn, this is averaged out, 10,000 to 20, they don't earn, but they receive $10,000 to $25,000 benefits, and they work about 550 hours. Okay, another group of mothers, this is a little bit lower benefit level, right? $5,000 to $9,999. They actually have average hours of work about 310. So this is a little bit unexpected because benefits are going down, but hours of work going down too. Another group with even lower benefits, 500 to 999, very low. They work about 890 hours. And yet another group with very low benefit, $1 to $99 a year. They work about 1,000 hours a year. Okay, another finally, mothers, single mothers with zero benefits have average hours of work of a little bit more than 1,500 actually. Okay, so what regression does is to find, you can see a negative relationship between the hours of work and benefits here. It's downward sloping. However, what regression does is formalizes this relationship. They find a line that best fits these points. Note that the line doesn't fit the points perfectly. So there's no perfect fit, right? It's impossible. Slope of this regression line is 110. What does it mean? Doubling the temporary assistance to needy families benefits reduces work by 110 hours if you calculate the elasticity, the slope of the line. So best fitting line has negative 110 slope. What did it mean? Doubling the benefits reduces work by 110 hours. So let's calculate elasticity from this because I mentioned elasticity. Let's convert this into elasticity. Average work effort is, average labor supply is 748 hours. So if you look at percent change in labor supply, right? You do a starting point, you can put 748 in the denominator. So, right, labor supply final minus initial divided by, we can put the average here actually in the, usually we do the initial point, but you can start from the initial point as the average point. You can start from average point as the initial point. So 100% rise in temp leads to, as a result, 15% reduction in hours worked. How did we find this? How did we find this? So what we did is, right, doubling 100% increase in benefits, reduced labor supply by 110 hours. Okay, and divided by, so that was the reduction when the benefits doubled. You can divide it by 748. This is percent change in labor supply, right? So how do you find elasticity? Is percent change in labor supply divided by percent change in benefits. 10th benefit. So I know doubling the benefits means benefits increasing 100%. Okay. We need to find the percent change in labor supply. I know labor supply is going down by 110 units. And starting point, let's say we start from average. Okay. So if you calculate this, this is a 15% reduction. So minus 15 divided by plus 100. Oh my gosh, Freddy Krueger effect. Minus 15, I'm going to rewrite it. Freddy Krueger. Plus 100. Okay, so you have 0.15, negative 0.15, which means this is a fairly inelastic response. This basically means in English, if the benefits are increased by 1%, labor supply declines by 0.15%. Okay, the impact is pretty small. Yeah. However, interpreting the result is potentially problematic because did the higher benefits cause lower labor supply? Maybe single mothers with greater taste for leisure get higher benefits due to the tax rate. Okay. So working mothers automatically get lower benefits. It could even be, okay, people who don't like to work could actually end up having more and more kids to qualify for higher benefits. Okay, therefore work less. So the relationship we showed in figure 3, this one may not be causal, folks. In figure 4, it's less obvious. Figure 4 less obvious because we don't know the underlying utility functions of the CPS respondents. Plus, they could be even having those preferences, right? Okay, so advantage of regression analysis. You can include control variables. You can include other independent variables I mentioned. It could be labor market income. It could be number of kids that may affect the dependent variable, which is my labor supply, in addition to temp benefits. You can, for sure, reduce the systematic differences between different groups using regression analysis, but regression does not guarantee causality. Okay? So, again, we might be able to control a variable for taste for leisure, that could be number of kids. In reality, kinds of control variables exist in the typical data sets like CPS are crude at best. It's really hard. So taste of leisure, as I said, might be proxied by education. So highly educated people are more likely to participate in the market. I want to work, so I better get high education. Number of kids in the household, right? I want to get education and a good career. I'm not going to go ahead and have more children than I can support. Age also could be an indicator for taste of leisure. In most cases, again, we cannot fully control all the variables, control for all the variables that will completely solve the problem. It's difficult to get rid of this bias totally, okay? So let's talk about quasi-experiments and structural modeling. These are a little bit stronger ways to establish causality, and we'll study that in part 5. I'll see you then.